Hello friends, my name is Ranjit Kumar Vishwakarma. Okay, today our topic will be pulse transfer function, which is the third unit of our digital control system. Okay, in this lecture, in this session, we will see what is pulse transfer function. Okay, so this is the definition of pulse transfer function. The pulse transfer function is a key tool for analyze and design discrete time control system, providing a mathematical representation of the relationship between input and output signal. Okay, like same as uh, transfer function in a control system, we have seen in transfer function in control system, that is T of S, which is nothing but Laplace transform of output to the Laplace transform of input at certain condition, that is zero initial condition, that is zero initial condition. Okay. Now the pulse transfer function is also known as jet transfer function. Okay, here in digital control system we will see the pulse transfer function is nothing but the jet transfer function. So in every case we have to find out the jet transform. Okay, so this is the basic block diagram, that is this is input response input, and that is output. This is again g of s, which is in the Laplace transform form. So this is the continuous data input linear system. Okay, now the transfer function we have studied in a control system, that is pulse transfer function is nothing but Laplace transform of the output to the Laplace transform of the input. Okay, where R of S is Laplace transform of input signal, which is nothing but R of t, and C of S is Laplace transform of output signal, that is C of t. Okay, now the block diagram, this is the basic block diagram. Okay, from here we will start how we can find out the pulse transfer function. Okay, so this is the input R of t. Okay, here we apply sampler. After sampling, the input signal will converted into discrete signal, and in discrete signal we will denoted it as a R star of t. Okay, after that this signal is sent to the G of S, okay, which is nothing but plant, and then we will get some response. Okay, so here R of t, R star of t, G of S. Okay, here we apply another sampler. Okay, and after this sampler the output will become C star of t. This is C of t, that is C of t, else C of S we can say, and this C of t is we are providing after sampler, and after that after sampler this it becomes C star of t. Okay, now from here we can write the transfer function like C of S is nothing but a series relation, that is R star of S. Just multiply these two signal, R star of S and G of S. I have multiplied here R star of S into G of S. Okay, now we will be starting on both side. Okay, when we will be starting on both sides, then we will get C star of S, CS whole star equals to R star of S, R star of S into G of S whole star. Okay, now after that C star of S, which is equals to R star of S of star and into G star of S. Okay, and C star of S, same C star of S, and equals to, always remember star function of the star function is always same function. Like if I am right, let's suppose this is R star of S. Okay, and again if we start this function, so again it will become R star of S, that is discrete signal. Okay, so I have right here R star of S whole to the power star whole to the star, that is same as R star of S and G star of S. Okay, now after that we have to find out G star of S, that is G star of S equals to C star of S divided by R star of S. Okay, now where G star of S is represent pulse transfer function, and the Now we have to take the Z transform of this pulse transfer function. Then we will get Z means star here G star of S. So directly whenever we will see star function, then that function is directly converted into the Z transfer function. Okay. So directly G star of S, it is written here. So directly it will become, when we apply Z transfer function, that is GZ. And here also I told you, whenever we will see star, and that star will convert it directly Z transfer. So C star of S and divided by R star of Z. Oh, sorry, R of Z. Okay, now this is the basic block diagram. This is the basic block diagram in Z transfer function. Okay. Now, the further topic is block diagram reduction. Okay. Now in this topic we will see how different block diagram means how uh, different blocks are given there, and how we can uh, means how we can calculate the pulse transfer function. Okay. So here I have added two blocks. Okay. First one is G1S and second one is G2S. Okay. So this is the input R of S, and some sampling we have applied here, and here also S2, that is same time period in same time period, that is T and T. Okay, so this R of S will become R star of S, and this C1, that is the output of the first response, first block, that is C1S, and after sampling we will get C1 star of S. Okay, now here C of S, that is my final response. Okay, so from this block diagram I can write C1S is equals to, that just multiplied these means after the sampler, that is nothing but R star of S, R star of S into G of S. Let's suppose this is equation first. After that, C of S equals to C of S. Where is C of S? C of S again multiply these two functions, and it will become C star of S, G2 of S. Let's suppose this is equation number 2. Now from equation number 1, we can starting this means equation 1, we will get C1 star of S and equals to, okay, so it will become again R star of S of star. So it will become directly R star of S, and this is G1 star of S. This is equation number 3, we can say. Okay, we can achieve. After that, from equation 2 and 3, okay, from equation 2 and 3, here C1 star is given. So in the place of C1 star, we can substitute the equation number 3, that is C1 star of S. So it will become like C of S equals to R star of S, G1 star S, G2 of S. Okay, now again, starting both sides, we will get C star of S, R star of S, and G star of G1 star of S. Now, this will same, it will become same, and G2 of S, it will become a star function. Okay, that is G2 of S. Now taking Z transform, so directly I told whenever we will take the Z transform of the star function, it will become directly C star of S is equals to C of Z. So here I can means I write here C of Z equals to R of Z, G1 of Z, G2 of Z. Okay. Now from here we can write C of Z, R of Z, that is input. So C of Z divided by R of Z equals to G1 of Z, G2 of Z. Okay, now reduction is in the single block diagram, that is R of Z, and it is provided to the, it is sent to the signal, that is G1 of Z, G2 of Z. Okay, after that we get a response. Okay, now when we add two block cascade using only one sampler, okay, only one sampler if you use, and that sampler is in the input side, then how the signal will become, how the response will become means pulse transfer function. So okay, now first we will multiply G1S, G2S. Okay, we can directly multiply. Okay, now for C of S, for C of S, first we multiply G1S, G2S. Okay, so I have multiplied here G1S, G2S. Now after that, C of S, we can write C of S equals to R star of S, G1S, G2S. Okay, now taking starting on both side. Okay, whenever I'm taking starting on both sides, just see the concept like these two function. Okay, G1 of S, G2 of S. Okay, I have right here G1 of S, G2 of S, and R star of S. Okay, this is star and starting of this function. Okay, R star of S whole star. Okay, now these two function will become like G1 of S, G2 of S whole star. And after that, when we apply means starting function, when we do the means do the calculation, means do the process steps, this means starting, then it will become G1 and G2 star of S. Okay, not it will become like a G1 star of S and G2 star of S. Okay, remember, whenever I'm going to apply like first, let's suppose G1 star. Let's suppose G1 star. Whenever I starting the function, it will become when one function is given here. Okay, but remember, if two function is given like G1 of S and G2 of S, two function is given. Okay, let's suppose two function is given, that is G2 of S. In that case, first we have to take the simple means in a single function like G1 of S, G2 of S, then it will become G1, G2 of S. Okay. Now after that we perform this execution, means this operation, that is G1, G2 star of S. Okay. So same I have did here, that is G1, G2 star of S. Okay. Now, and always remember G1 star of S, G2 star of S, which is not equals to G1, G2 star of S. Okay, remember this point. Okay, keep this as a note. Okay, this is very, very important. Now, also, again, after that function is came, now we will take the Z transform, then it will become C of Z equals to R of Z, G1, G2 of Z, and again, this is the input, and we send this input to the this side, left hand side, that is C of Z divided by R of Z, which is equals to G1, G2 of Z. Now I have written here that is G1 of Z, G2 of Z does not equals to G1, G2 of Z. This is the same. If I take the Z transform, then it will become G1 of Z, G2 of Z, and it will become G1, G2 of Z. Clear? Now, this is the closed loop control system. Okay. Previous one, the block diagram is like open circuit. Okay. Here, no feedback is given to the means from output to the input. Now we will talk about that is closed loop control system. Okay. This is the closed loop control system. First of all, see this diagram. That is a block diagram of control loop, means closed loop control system. This is the R of S. This is error detector. This is error signal. Okay, and here I'm applying some sampler. After sampling, this error signal will become E star of S, and again this signal is sent to the this plant, that is G of S, and response we will get the response. Okay, in any case like some means modification is there, then we provide this C of S into the some sensor, and that sensor again means it is controlled to the output. Okay, this sensor will control output, and this signal is sent to the input, and again this process will going on. Now this is the block diagram. Achha. From block diagram we can write E of S. E of S, that is R of S minus, simply here we get just C of S is coming to the this block, sensor block, H of S. So here it will become C of S and H of S. Okay, so we can write E of S, that is error signal, is R of s minus of h of s c of s, which is nothing but equation number first. And after that, c of s. Where is c of s? C of s, we can write e star of s into g of s directly. Just multiply this signal to this signal, and it will become e star of s into g of s, that is c of s. Okay, let's suppose this is equation number 2. Now from equation 1 we can write e of s equals to r of s h of s. Just substitute the value c of s from this from equation number 2, that is g of s e star of s in the place of c of s. Then it will become this equation. Okay, now starting both sides, so it will become e star of s equals to r of s minus h of s g of s e star of s and star. Okay, whole star. Again we will apply the operation, that is e star of s equals to r star of s minus g h star of s e star of s. Okay, because e star of star function will become same function, that is e star of s. Okay, and here I told, like whenever two function will be given, first of all we have to make a single function and then we apply the starring operation. Okay, now e star of s, just put this means keep this side, means transposing into LHS side, and it will be and I have taken e star of s as a comma, so it will become 1 plus 1 plus gh star of s, and this function is common, I have taken here. Now r star of s will become in the means it is same in the right hand side. Now we have to calculate e star of s, so e star of s, just send this signal into this side, RSS side, so it will become r star of s divided by 1 plus gh star of s. Okay, now from equation 2, that is c of s equals to e star of s into g of s. Okay, so I have taken again starting this equation, means equation number 2, so it will become c star of s equals to e star of s g star of s. Okay, now substitute this equation, means this relation here over here, so it will become r star of s divided by 1 plus gh star of s g star of s. Okay, okay, so just take r star of s, that is input to the LHS side, so that is comes divided by the c star of s divided by r star of s equals to g star of s divided 1 plus g star of h. Okay, just think this is also a star function and this is also a star function. So first of all, means this is also a star function, this is also a star function, so no need to make a single function, just take z transform, so it will become c star of s, that is r c of z and r of z, which is equals to g of z divided 1 plus gh of z. Okay, now error and feedback sampling. After that, means after this block diagram, just we sample uh, error signal. Okay, sample this error signal as well as feedback, this feedback sampling. Okay, means before this feedback I have providing one sampler over here, so it will change this c star, means the which is a continuous signal, into discrete signal. Okay, after sampling, so we will see the derivation. E of s, this error signal will become directly r of s minus b of s. I'm just taking, suppose that is b of s, which is nothing but h of s into c star of s. Okay, h of s c star of s. This is question number first. And error signal, this error signal is become okay. Now starting this function, this is starting equation 1. Whenever I'm starting equation 1, so it will become e star of s equals to r star of s minus b star of s, equation number 2. Okay, so e star of s g of s whole star h of s equals to b of s. I have just substitute the value of b star of s and keep this b star of s in means this side. Okay, and taking h star of s. So wait, E star of S, E star of S, G of S, H of S equals to, okay, now here I am writing B of S. Okay, how we can write B of S? Just from this sampling, just apply from this sampling and go to the this one, means follow this closed loop path up to here, B of S. So it will become E star of S, G of S. Okay, now these two function is providing by a sampler. So this sampler will do means all this function to whole square. Okay, means E star of S into G of S whole to the star. Okay, so same I have written here. After that, signal is multiplied with H of S. Otherwise, you can directly write first to C of S equals to E star of S and G of S. You will get the same result. Okay, don't worry. You will get the same result, that is C of S. And after that, starting this function, starting means ki I have to provide this signal, send this signal via sampler S2. So it will become C star of S equals to E star of S, G of S whole to the means whole starting function. So okay, same signal I have written here, same function I have written here. Okay, there is no any difference. Okay, and that is a very good thing. Ki directly you just apply like a closed loop. Okay, then you will get means you can remove this step. Okay, you can eliminate this step. No need to calculate like C of S like this way. Directly you can write. Okay, now after that, when we perform this star function, so it will become like this. Okay, B of S, and again just starting this function, after starting this function, so it will become every function is as a star function, that is S, and this is B star of S. Now from equation 2, this is the from equation 2. Okay, we can substitute value here, means B star of S from this equation. It will become E star of S equals to, that is same, E star of S equals to R star of S. Here also this is same, but in place of B star of S we can substitute this value, that is E star of S, G star of S and H star of S. Okay, now again transposing this term in left hand side, then it will become, and again I have taken E star of S as a common, so it will become 1 plus G star of S, H star of S, and which is equals to R star of S. Okay, now send this signal into this side, right hand side, so it will become R star of S divided by 1 plus uh, 1 plus G star of S, H star of S. Okay, now E star of S, G of S equals to C of S. That is, I think this is the first equation. First, no. Okay, here this one I have taken. Okay, this one I have taken. Where? Yeah, also here. E star of S, G of S, which is equals to C of S. Okay, now again starting this function, we will get, okay, after that same operation we have to perform here. Okay, then we will get like C star of S, R star of S. Okay, so it will become G star of S divided by 1 plus G star of S, H star of S. Okay, don't confuse here. I have just substituted the value of E star of S. Okay, that is nothing but R star of S divided by 1 plus G star of S and H star of S. Okay, again here every function is in the star function, so directly we apply Z transform. Okay, no need to convert this function into a single, means in a single variable, that is in S domain. Okay, now okay, this function means come Cz divided by R of Z, which is equals to G of Z divided 1 plus G of Z H of Z. Okay, now this is the third diagram, this third block. Here we just add the sampling in input side. Okay, now we will see here how it will affect. Okay, how it will affect. Okay, we have applied here sampling in the input side. Okay, and just see, this is the uh, this is the basic, you can say, like closed loop system for the control system. Okay, we have studied in BTech level. Okay, that is nothing but C of S divided R star of S. Okay, just think about this diagram. Means you must see in BTech. This is the basic, and just here, instead of R of S, we just write R star of S. Okay, it may be any other value, no? So I can take it as like, let's suppose, what I can say, uh, any function, like you can say any Laplace transform function, that is unit impulse. If you will take that, it will become one. Unit step, you will take that, it will become 1 by S. So any function R star, it is just a denotation. Just think, it is input and it is the denotation of the input R star of S. Then you will get the, this is the same block diagram. Okay, same closed loop system. So directly we can write closed loop system. We know that C of S divided R star of S equals to G of S divided by 1 plus GH, uh, G of S, H of S. Okay. Now taking the starting on both sides. Okay. Now here, just first of all, we have to convert, because in right hand side, everyone is in the S domain. No one is in the, means a star function. Okay, so first of all, we have to make this all function into the single function. Like, first of all, we have to write this as a G divided by 1 plus G H of S. Means this is the main function. Okay, and in the domain S. So now we will apply, means starting, means we starting the on both side, we will get C star of S, R star. This is already in star function, so no need to make in one, means one variable, one domain, that is S domain. Directly we can write C star of S divided by R star, but it will become like this: G divided by 1 plus G H star of S. Okay, after that, taking Z transform, you will get like this value. Okay, this is the our means pulse transfer function. How we can calculate pulse transfer function from the block diagram, and also I have discussed, that is block diagram reduction. Okay, so you can whenever you will get like many more, many, means more plant is there. Like, just think here, G of S only is there. Just suppose if I am adding here one more plant, one more sample, that is means plant. Let's suppose that is G2 of S. Okay, and again I have providing here one sampler. Okay, so don't be confused, just apply, means just follow the same, just follow the same steps. Like, whenever you will see that is sampling, just start from the means first, means start from first sampler and go till end. Okay, like, let's suppose ki here one sampler I have added. Okay, that is G12. So how we can write B of S? B of S will, I can write E star of S. Okay, which multiplied with G of S. Now sampler I have added here, so just it will do the star of this. Okay, sampler means starting the function, means discretize the function. Now after starting function, it is multiplied with G2 of S. Okay, so I have multiplied here G2 of S. Again, just see, this signal is go where, again, sampler S2. So again I have to starting this function. Okay, now multiplied with H of S, and just think this will become our B of S. Okay, again you can perform the operation. Like, first this bracket will be here, that is E star of S, and it will become G star of S. Okay, and yeah, and after that, this G2 of S. Now again star of S, and this is H of S, and again it will become, that is E star star will become same function. Again star star will become same function, and this function don't have star function, so it will become G2 star of S. And this is same, no change. Okay. Okay, now this is the P of S. Like this way, you can calculate the pulse transfer function. And whenever you will see, like, this one last question, no? Just think here. Means just do some modification here. Like whenever you will see there is no any starting star function in the left hand side. Okay, like in denominator and numerator and denominator. First of all, you have to convert this function like this function, and then you can apply whenever you apply starting function na, so it will become like this way. After that z transform, you will get this value. And always remember this g of z divided by 1 plus g of z h of z, which is not equals to g divided by 1 plus g of z h of z of z. Okay, yeah, means which is not equals to, just saying that okay, these two functions are not equals. Okay, okay, let me write it again. That is g divided 1 plus g of h. These two functions are totally different. Okay, the meaning of this function and this function is totally different. Okay, so this chapter I have discussed very brief, and any doubt you just comment it, and mm, and the PDF I will attach in the description. Okay, so you can find out the PDF of this lecture. After that, just subscribe my channel also. Okay, bye bye, thank you.